Welcome back to our series Understanding CBET. And in our continuation today, we've been looking at performance criteria weighting. And we started looking at how do we populate the PC weighting tool using critical aspects are one of the factors that you can use to populate and weigh performance criteria. And today, we are going to look at how we are going to populate the same tool using number of tasks. And we did talk about tasks in our previous tutorials. And we did say that number of tasks basically means performance criteria. So those are the tasks that you're going to conduct to achieve a particular duty, and that is the element. And therefore, you can use the number of tasks in our occupational standard, and you can use that now to allocate or calculate your weights based on the number of tasks. And we are talking about the number of tasks. It involves assigning weight to each performance criteria based on the number of tasks in an element. We did say that elements are organized into different number of performance criteria. And you'll find that when you look at a unit of competency, each element has its own performance criteria, and that is the tasks that you need to perform to achieve that learning outcome. So, how then do we use the number of tasks to populate performance criteria weighting tool? So, that is what we are going to do today, and let's jump to the practical bit so that we see how we use the number of tasks to populate our performance criteria weighting tool. So I'm going to use the same unit of competency, and that is performing methodological tests, so that we're able to understand how then do we calculate our weights using number of tasks. And the number of tasks we are talking about is each element has its own number of performance criteria. So if you can look at this element one has 5 PCs, and then element 2 has up to 6 PCs. So this is what we call the number of tasks that you need to perform to achieve this learning outcome. So again, for us to understand really what I'm talking about, I've created the same rough sketch of what I need you to understand. The same we did with our performance, rather our critical aspects. I've again used the same tool, but this time we want to look at the number of tasks for each element. And you're going to see the difference it has when you use critical aspects and you use the number of PCs. Remember, when we talk about critical aspects, we said it follows a certain direction. Is it the same with the number of performance criteria or the number of tasks? So let's see how it's going. So allow me to have it on the same window. So in this case, we want to look at this PC. This unit of competency has how many elements? So you look at your elements, it has up to 6 elements. So just write up to 6 elements. So if it is 10, based on your unit of competency, then you're going to have more, or depending on the number of elements that you have for that unit of competency. So let's look at the number of tasks for each element. So if you look at element 1, element 1 has 5. So come here and say 5. Element 2 has 1, 2, up to 6. So you just count. So what are we seeing? We are saying that element 1 has 5 uh, number of tasks or performance criteria. Element 2 has 6. Element 3 has 4. So if you look at element 3, 4, and 5, share the number of tasks or number of performance criteria. Then number 6, element number 6 has 3 performance criteria. So let's dive in and see how we're able now to work out some of these um, items that we have. So you've looked at the elements, you are now looking at the number of tasks. So let's look at ranking. And I've used two different words. You have unique rank and ideal rank. So talking about unique rank, we are saying that each element should have its own unique ranking. So in this case, let's see which element is ranked the highest. So in this case, you have this one will be ranked the highest based on the number of tasks, followed by element number 1. Then we have 3, 4, and 5 sharing the same number of tasks. So when you're talking about unique rank, that means each element should have its own unique position. So in this case, we can assume this will be 4, then this will take number 3, then this will take number 2, and finally this will take number 1. So this is what we talk about unique ranking, that each element has its own position. But again, because element number 3, 4, and 5 are sharing, that means you're going to use what we call the ideal rank because they have to share. So if you are having the same score, then you're going to share the same rank. So how again are we going to now ensure that 3, 4, and 5, because they have the same number of tasks, but again they are ranked based on unique values as 4, 3, and 2. Then how do then share the same position? So you're going to work it out like this. So let's look at 3 because 3, 4, and 5, they need to share the same rank or position. So in this case, if you had to calculate what is the ideal rank for element number 3, then you're going to look at what is the unique rank. So in this case, you'll say 4 plus 3 plus 2. And then this one we divide by, so that we get the mean, we divide by 3. So in this case, uh, the value will be, 3. So element number 3, 4, and 5 are going to share the same position. So again, we'll talk about the same. So element number 2 will be 6. But now the ideal rank for this one will be 3. So these are going to share the same position. And this will remain 1. So basically, I wanted you to see that I'll repeat again. Element, we have 6 elements for that unit of competency, and you have looked at for each element how many number of tasks do they have or performance criteria. So element 1 had 5 like that. But we are seeing that element 3, 4, and 5 are actually having the same number of tasks. And that means they need to be ranked the same, or they need to share a particular rank. But when you're looking at that, how do you get the ideal rank for these that share positions? And that's why we came with unique rank. Ideally, each individual score should have its own unique rank. And that's how we said we assumed 3, 4. So this will take 4. Or either way, you can even say this is 3, 3, 2, 4. And then we need to now find what is the ideal rank, now the real position for that element. And you have looked at, because they share the name, the number of tasks, and they have different unique position, you're going to add them. So 4 plus 3 plus 2, you get 9. And then you get the mean. So you divide by 3, and then we get these 3. So they're going to share the same rank, and that is 3, 3, and 3. Assume there were 2. Then it will be 4, 4 plus 3 divided by 2. If there was 6, then you take the unique rank divided by 6, so that you get which ideal rank will the same, elements that have the same number of tasks, then have. Therefore, for ideal ranking, element number 1 will be the same as 5, element number 2 will be 6, then element 3, 4, 5 will share the same rank, and that is 3. Now let's move on to weighting using the 100%. And we did talk about that CDAC has given us a formula so that we're able to get that. And we say that is an nth rank divided by total ranking, then just multiply by 100. So ideally, we need to get the total for this, because this is now what you're using. So this will give us, so this is 21. So just say total. So how then do we get the weight for element number 1? So it will be 5 divided by 21 times 100, be around 23.8. So you do that for all the elements. So we've already calculated our weights using the formula. So again, get the total for that. So of course this should be 100. So let's move in and see another area, and that is weight by factor. And we did talk about this in our previous video for tutorial when talking about critical aspects. But again, we did talk about how do you derive your factors. We said one thing that you need to factor is when you're talking about factors, usually check your lowest weight. And in this case, our lowest weight is 4. And then look at element number 6. Are you able to distribute 4 marks in that number of elements? Okay. So if something that you can able to distribute, then you don't need to use a factor. But if you feel you can't distribute, remember you're looking at level 6, that is 50 by 50, uh, 50% theory and 50% practical. So able to distribute the weight 4, say, into 5 critical aspects. Not really critical aspect, but number of performance criteria. So if something that you can distribute, then you don't need to introduce a factor. But if you can't, then you need to introduce a factor that you're able now to multiply your lowest uh, weight. Then you can use that now, your results now to distribute the marks. So let's see in this case, our lowest marks is 4. Are you able to distribute these marks? So you go back to your OS and look at, this is element number 6. It has, of course, 3 tasks or 3 performance criteria. So am I able now to distribute the 4 marks into 3 elements? So to me, I need to use a factor. Then again, what is the value that I need to use? We said that there's no formula for which factor that which value you need to use. But again, we did talk about how that value that you're going to choose affects your assessments. Yeah. So what is the ideal factor? We said when you use factors that are high, say 100, 20, those factors, then imagine you're going to multiply by your total weight, and that is 100. So if you chose 10, then you're going to multiply 10 by 100, you get 1,000. And that tells you the number of assessment that you need to conduct for that particular term. So when you use high values, then you're going to have a high number of assessments that you need to distribute across that term. Another way that will make it easy for you to know which factors should use is just to see the number of tasks that you have or the number of performance criteria. And then you can use that to be your factor. In this case, my weighting of 4 in this element has 3 tasks. So I'll use this as my factor. Okay. Maybe at least that makes sense at times when you can't find which is the exact factor that I need to use. So look at your lowest weight and then look at the number of tasks it has. Then you can use that value to make it your factor. So in this case, I've used 3 because element number 6 has 3 performance criteria. Maybe yours will be 2. Maybe yours will be 1. But again, we did say that each element should have specific number of performance criteria, at least not less than 3 to 5 performance criteria for each element. So in this case, I've used 3 because my lowest weight, and that is element 6, has 3 number of performance criteria or number of tasks, and that's why I'm using this. Maybe yours will be different, so that at least you have a reason why I chose that number. So you're going to multiply everything here by 3. So when that is done, now you can do your totals. And of course, when you have 3, you multiply by 100, you get 300. So when you add all these, then you'll get the total 300. So what are these 300 tells you? You have 300 marks to distribute across all assessment for that term. So again, that depends with you. You can do 3 cards of 100, you can do assignments and many other. Just to ensure that you're able now to accomplish the 300 marks. So for each weight of elements, so element number 1 has a 71.4. So you go like that. And this is what you're now going to distribute across both theory and practical. So in this case, if you had element number 6 has 12, then you can see I can able to distribute 50% and 50% to theory and practical easily in my 3 tasks. Okay. Now that understood, you are going to use these figures now to populate our performance criteria weighting tool. So in our next video, we'll now start populating this sample PC weighting tool using the different factors that we have used, the critical aspects, the number of tasks, now to populate this tool. So thank you. Please continue to subscribe, like, comment, and share these videos. Thank you for your support.